All right, let's get into it. Today, we're going to unravel one of the greatest scientific detective stories ever told. It's all about how we figured out that the solid ground we're standing on, well, it's actually moving all the time. It's a tale of a crazy idea, a ton of clues, and a puzzle that took forever to finally solve. So, where does a story like this even begin? It all starts with a super simple observation, the kind of thing you might notice just staring at a world map. You look at the coastline of South America, you look at the coast of Africa, and you just can't help but think, hey, wait a minute, what if those two pieces used to fit together? That little thought, that was the first big clue in this whole mystery.
And the first detective on this case was a German scientist, Alfred Wegener. Back in the early 1900s, he took that simple puzzle piece idea and ran with it. He turned it into a full-blown scientific hypothesis that, let me tell you, sounded completely nuts to almost everyone at the time.
He called his idea continental drift. Okay, right there, that's your first key vocabulary term. If you're studying this, you absolutely need to know it. Continental drift. It's the simple but powerful idea that continents aren't stuck in one place. They actually drift around the globe. And Wagner said they were all once connected. And that one giant landmass, it had a name, Pangaea. It literally means all Earth. That's another huge term for your notes. Wegener wasn't just saying continents moved. He was saying that every single continent we see today was once part of this one massive supercontinent. Now, a good detective can't build a case on just one clue, right? You need evidence. So Wegener started hunting, and he found clues scattered all over the world, right there on the continents themselves. First up, the landforms. It was more than just the coastlines fitting together. He saw that huge mountain ranges like the Appalachians here in the US seemed to just end at the coast. But then, a nearly identical mountain range would pick right back up over in Scandinavia. It was like they were a single chain that had just been ripped apart. But the fossil evidence? This is where it gets really convincing. Scientists were finding fossils of the exact same ancient plants and animals on continents that are now separated by thousands of miles of ocean. I mean, think about it. How could a little freshwater reptile, the Mesosaurus, swill across the entire Atlantic Ocean? No way. It couldn't. The only logical explanation was that the continents themselves had been connected. And just so we're all on the same page, a fossil is just the preserved remains or even just the traces of an ancient living thing. For Wegener, these fossils were like finding matching fingerprints at two different crime scenes, proving these continents had a shared past. And Wagner's last big piece of evidence came from climate clues, and these are kind of wild. He found deep scratches in the rocks of South Africa, the exact kind of scratches that giant glaciers leave behind. But South Africa is warm. And even weirder, geologists found coal in Antarctica. Coal comes from ancient tropical swamps. The only way any of this makes sense is if those continents used to be in totally different parts of the world. So Wegener had it all laid out. The matching puzzle pieces, the connected mountains, the impossible fossils, the bizarre climate clues. I mean, he had a rock-solid case. And yet, the scientific community pretty much laughed him out of the room. They completely rejected his idea. So you have to ask, why? With all that evidence piled up, why didn't they believe him? What was the one critical missing piece that kept this theory on the shelf for like 50 years? Well, the answer was actually pretty simple. And for Wegener, it was devastating. He couldn't explain the mechanism. He knew what was happening, the continents were moving, but he had no idea how. What force on this planet is powerful enough to shove an entire continent? He didn't have an answer. So decades pass. And then the missing piece of the puzzle finally turns up in the last place anyone really expected to look: the dark, mysterious bottom of the ocean. New technologies like sonar started mapping the seafloor, and it revealed a whole new world. And what they found down there was this process: seafloor spreading. Okay, this is the big one. Another absolute must-know vocabulary term. Scientists found these huge underwater mountain ranges called mid-ocean ridges, and they realized they were literally splitting apart. Magma was coming up, creating new ocean floor, and pushing the old floor and the continents with it, away from the center. This was the engine. This was the how that Wegener was missing. And the proof was undeniable. They found special pillow lava, which can only form when lava cools super fast underwater.
They found these amazing magnetic stripes in the rock on both sides of the ridge, like a perfect mirror image. And finally, the ultimate proof came when they started drilling into the ocean floor itself.
This is where it all clicked. The rock samples they brought up were brand new, the youngest rock, right at the center of the ridge. And the farther away they drilled from the ridge, closer to the continents, the older and older the rock got. That was the smoking gun. It proved without a doubt that the seafloor was spreading out from the middle like a giant, slow-moving conveyor belt. So now, finally, we have all the pieces. We've got Wegener's original clues from the land, and now we have this powerful new evidence from the bottom of the sea. It's time to put it all together into the grand theory that we have today. And here's a really simple way to remember it. Wegener's continental drift, that was the what. It was the observation that continents are moving. Seafloor spreading, that was the how. It was the mechanism that actually moves them. And when you put the what and the how together, you get the complete theory of plate tectonics. And here's the formal definition. Another one for your notes. Plate tectonics is the theory that Earth's crust isn't one solid shell. Instead, it's broken up into these huge, rigid slabs we call plates. And those plates are constantly, slowly on the move. But we can actually go one level deeper. We know seafloor spreading moves the plates. But what's causing the seafloor spreading? What's the ultimate engine driving this whole colossal system? The answer is deep down inside the Earth, in the layer called the mantle. The process is called convection currents. Honestly, the best way to picture it is just a pot of boiling water on a stove. The hot water at the bottom rises, spreads out at the top, cools down, and then sinks. The same basic thing is happening with the hot, gooey rock inside our planet. So here's how that giant conveyor belt works. Deep inside the Earth, hot magma rises up. It moves sideways underneath the plates, and as it moves, it cools down, gets heavier, and sinks back down. This slow, constant, circular motion is what drags the massive tectonic plates along for the ride, year after year for millions of years. Okay, let's wrap this up with the key takeaways. If you're studying for a test on this, here are the 3 big things to lock in. First, continental drift. That was Wegener's idea. The what. He had the evidence, but not the how. Second, seafloor spreading. This was the how, the mechanism that pushes everything apart. And third, plate tectonics. That's the whole shebang, the complete theory we have today, all powered by those convection currents down in the mantle. And that pretty much closes our detective story. But the real process is still happening. Right now, the plates are moving at about the same speed your fingernails grow. So that leaves us with one last big question to think about. If this keeps going, what do you think the Earth will look like in another 250 million years?